Music technology is any technology, such as a computer, an effects unit or a piece of software, that is used by a musician to help make music, especially the use of electronic devices and computer software to facilitate playback, recording, composition, storage, mixing, analysis, editing, and performance. Music technology is connected to both artistic and technological creativity. Musicians are constantly striving to devise new forms of expression through music, and physically creating new devices to enable them to do so. Although the term is now most commonly used in reference to modern electronic devices such as a monome, the piano and guitar may also be said to be early examples of music technology. In the computer age, however, the ontological range of music technology has greatly increased, and it may now be mechanical, electronic, software-based or indeed even purely conceptual. Education. Music technology is taught at many different educational levels, including K-12 through college and university. The study of music technology is usually concerned with the creative use of technology for recording, programming, manipulation, mixing and reproduction of music. Those wishing to develop new music technologies normally train to become an audio engineer working in R&D. History. Early pioneers included Luigi Russolo, Pierre Schaeffer, Pierre Henry, Edgar Varese and Karlheinz Stockhausen. Music technology has been and is being used in many modernist and contemporary experimental music situations to create new sound possibilities. Synthesizers and drum machines. A milestone in electronic instrument development was the invention of the transistor in 1947. With this new miniaturized component, it was possible to make synthesizers much more portable and complex. A new breed of synthesizers appeared, mainly in America. These were capable of producing a vast range of complex sounds. Later versions often incorporated automatic rhythm units. In the 1970s, the American domination of the market was relinquished to the Japanese. Robert Moog's synthesizer designs in the 60s were a significant advancement in the field over its predecessors. This was partially owed to new technologies that became available, such as the newly developed semiconductors. These new instruments were less expensive and became available worldwide. They had more popularity than any synthesizer from the past. The release of Wendy Carlos' album Switched On Bach in 1968 brought Moog's synthesizer to the general public's attention. The album demonstrated that, besides creating strange sounds, the synthesizer could be used to make beautiful music. Some of the most iconic synthesizer include the Moog Mini, Moog Odyssey, Yamaha CS80, Korg MS-20, Sequential Circuits Prophet 5, Fairlight CMI, PPG Wave, Roland TB303, Yamaha DX7, Roland Alpha Juno, and the Korg M1. Drum machines. Sly and the Family Stone's There's a Riot Goin' On started a new era, that of the drum machine. However, it was not the first album to use one. Drum machines have been around since 1949 with the Chamberlin Rhythmate. Drum machines create sound by playing back pre-recorded samples at a rhythm that is programmed by a musician. Early drum machines sounded drastically different than the drum machines that gained peak popularity in the 80s and defined an entire decade of pop music. Some iconic drum machines include the Alesis HR-16, Korg Mini Pops 120, EMU SP-12, Electron SPS-1 Machine Drum, Roland County Route 78. Pia Programmable Drum Set, Lin Electronics Lindrum, Roland TR-909, Oberheim DMX, and the Roland TR-808. Sampling technology. Digital sampling technology, introduced in the 80s, has become a staple of music production. Devices that use this, known as samplers, save a sound digitally, and replay it when a key or pad on the device is triggered. Samplers can alter the sound using various audio effects and audio processing. Sampling has its roots in France with Musique Concrète. In the 80s, when the technology was still in its infancy, digital samplers had a price range of tens of thousands of dollars. These were out of the price range of most musicians. The first sampler released was the 8-bit emulator IIN 1981. Its successor, the Emulator 2, listed for $8,000. Many samplers were released during this period with high price tags. The K2000 and K2500 are more examples of this. The first affordable sampler, the Akai S612, became available in the mid-80s and retailed for a price of $895. Many other companies released affordable samplers around the same time: the Mirage sampler, the Oberheim DPX-1, and even more by Korg, Casio, Yamaha, and Roland. Some important samplers include the Akai Z4, Z8, Insoniq ASR10, Roland V Synth, Casio FZ1, Kurzweil K250, Akai MPC60, Insoniq Mirage, Akai S1000, EMU emulator, and Fairlight CMI. One of the biggest developments of sampling technology was the creation of hip-hop in the early 1980s. Before affordable sampling technology was readily available, would use a technique pioneered by Grandmaster Flash to manually repeat certain parts in a song by juggling between two separate turntables. This can be considered as another form of sampling. Almost every recording studio in the world is digital now, and many samplers exist in the digital-only realm. This new generation of digital samplers are capable of reproducing and manipulating sounds in ways that have never before been possible. New genres of music have formed because of this, and would be impossible without it. Advanced sample libraries have made complete performances of orchestral proportions able to be built up with such realism that it is sometimes difficult to judge whether the music originates from a live performance or from computer synthesis. Modern sound libraries allow musicians to have the ability to use the sounds of any instrument in their productions. The introduction of MIDI. At the NAMM show in Los Angeles of 1983, MIDI was first revealed. A demonstration at the convention allowed two previously incompatible analog synthesizers to communicate with each other, enabling a player to play one keyboard while getting the output from both of them. This was a massive breakthrough in the 80s as it allowed synths to be accurately layered in live and studio applications. Sequential Circuits Prophet 600 was the first commercially produced keyboard with a MIDI interface. In 1985, several of the top keyboard manufacturers created the MIDI Manufacturers Association. This newly founded association was trusted with the task to standardize the MIDI protocol by generating and disseminating all the documents that pertained to it. With the development of the MIDI file format specification by opcode, every music software company's MIDI sequencer software could read and write each other's files. Since the 1980s, personal computers developed and became the ideal system for utilizing the vast potential of MIDI. This has created a large consumer market for software such as MIDI sequencers and digital audio workstations. Some universally accepted varieties of MIDI software applications include music instruction software, MIDI sequencing software, music notation software, hard disk recording, editing software, patch editor, sound library software, computer-assisted composition software, and virtual instruments. Current and future developments in computer hardware and specialized software for MIDI applications make the frontiers appear infinite for an ongoing music revolution. Computers in music technology. Computer and synthesizer technology joining together changed the way music is made, and is one of the fastest changing aspects of music technology today. Dr. Max Matthews, a telecommunications engineer at Bell Telephone Laboratories Acoustic and Behavioral Research Department, is responsible for some of the first digital music technology in the 50s. Dr. Matthews also pioneered a cornerstone of music technology, analog to digital conversion. The first generation of professional commercially available computer music instruments, or workstations as some companies later called them, were very sophisticated, elaborate systems that cost a great deal of money when they first appeared. They ranged from $25,000 to $200,000. The two most popular were the Fairlight and the Synclavier. Reduced prices in personal computers caused the masses to turn away from the more expensive workstations. Advancements in technology have increased the speed of hardware processing and the capacity of memory units. Software developers write new, more powerful programs for sequencing, recording, notating, and mastering music. Modern-day music sequencer software, such as Pro Tools, Logic Audio, and many others, are perhaps the most widely used form of contemporary music technology. Such programs allow the user to record acoustic sounds or MIDI musical sequences, which may then be organized along a timeline. Musical segments can be copied and duplicated ad infinitum, as well as edited and processed using a multitude of audio effects. Contemporary classical music sometimes uses computer-generated sounds, either pre-recorded or generated, manipulated live, in conjunction or WIKT, juxtaposition with classical acoustic instruments like the cello or violin. Classical and other notated types of music are frequently written on scorewriter software. Many musicians and artists use patcher-type programs, such as PD, Vigil, Max, MSP and Audio Mulch, as well as digital audio workstations or sequencers, and there are still a significant number of people using more traditional, software-only approaches such as C-Sound or the Composer's desktop project. Music technology includes many forms of music reproduction. Music and sound technology refer to the use of sound engineering in both a commercial or leisurely, experimental manner. Music technology and sound technology may sometimes be classed as the same thing, but they actually refer to different fields of work, the names of which are to some extent self-explanatory. But where sound engineering may refer primarily to the use of sound technology for mediological purposes. Music technology timeline. 1874. Elisha Gray's musical telegraph. 1876. Alexander Graham Bell completed his designs for the telephone. 1877. Thomas Edison and Emil Berliner simultaneously invented the first prototypes of the phonograph. 1888. Thomas Edison introduces the electric motor-driven phonograph. 1896. Edwin S. Votey completes the first pianola. 1898. Valdemar Poulsen patents the telegraphone. 1906. Thaddeus Cahill introduces the telharmonium to the public. 1906. Leda Forrest invented the triode, the first vacuum tube. 1910. Vladimir Baranov-Rasina constructed the piano optophonique. 1912. Major Edwin F. Armstrong is issued a patent for a regenerative circuit, making radio reception practical. 1915. Lee De Forest created the Audione piano. 1917. Leon Theremin invented the prototype of the Theremin. 1921. First commercial IM radio broadcast made by KDKA, Pittsburgh, Pennsylvania. 1926. George Mager presented his electronic instruments in the Sphärophon line. 1927. Pierre Talon and Krug Bass invent the cellular phone. 1928. René Bertrand invents the dynaphone. 1928. Fritz Flumer patents a system for recording on paper coated with a magnetizable, powdered steel layer, a precursor to tape. 1929. Lawrence Hammond created the first Hammond organ. 1929. Nikolai Obakov commissioned Michel Billaudot and Pierre Duvalier to design the sonorous cross. 1929. Peter Lertis and Bruno Hellberger developed the Hellersion. 1930. Robert Hickok Omelettes the Westinghouse organ. 1930. Friedrich Trautwein invents the trautonium. 1931. Alan Blumlein, working for EMI in London, in effect, patents stereo. 1932. Nicholas Langer built the Emicon. 1932. Yevgeny Alexandrovich Sholpo constructed the Variophone. 1932. Harry F. Olson patents the first cardioid ribbon microphone. 1933. Ivan Eremiev invents the gnome. 1934. Milton Taubman constructed the Electrond. 1935. BASF prepares first plastic-based magnetic tapes. 1936. Harold Bode designs the Warbo-Foreman organ. 1936. Oscar V. Erling and Winston Koch designed the Groston orgel. 1937. Orson Welles, first director to use studio electronics, during his broadcast of War of the Worlds. 1938. Georges Genny develops the Ondio line. 1938. Benjamin B. Bohr of Shaw Brothers engineers a single microphone element to produce a cardioid pickup pattern. 1939. Homer W. Dudley invented the parallel bandpass vocoder. 1940. Carl Wagner early development of voice synthesizers, precursors of the vocoder. 1940. Homer W. Dudley introduced the Voda speech synthesizer. 1940. The Hammond Organ Company releases the Solovox. 1941. Commercial FM broadcasting begins in the U.S. 1944. Harold Rhodes built the first prototype of the Rhodes piano. 1945. The Hammond Organ Company commissioned John Hannett to design the Hannett synthesizer. 1946. Jennings Musical Instruments releases the Univox. 1946. Raymond Scott patented the orchestra machine. 1947. Constant Martin constructed the claviolin. 1948. Bell Laboratories revealed the first transistor. 1948. The Microgroove 33 to 1/3 of a revolution per minute vinyl record is introduced by Columbia Records. 1951. Pultec introduces the first active program equalizer, the EQP1. 1952. Harry F. Olson and Herbert Bellar invent the RCA synthesizer. 1952. Osmond Kendall develops the Compositron for the Canadian branch of the Marconi Wireless Company. 1955. Ampex develops CellSync, making audio overdubbing practical. 1956. Les Paul makes the first 8-track recordings using the CellSync method. 1956. Raymond Scott develops the Clavivox. 1958. First commercial stereo disc recordings produced by Audio Fidelity. 1958. Evgeny Merzin along with several colleagues create the ANS synthesizer. 1958. At Texas Instruments, Jack Kilby creates the first integrated circuit. 1959. Daphne Oram develops a programming technique known as Aramix. 1959. Wurlitzer manufactures the Sideman, the first commercial electronic drum machine. 1963. Kaya Electronics produces the DAR-20. 1963. The Mellotron starts to be manufactured in London. 1963. Philips introduces the compact cassette tape format. 1963. Paul Ketoff designs the Synket. 1964. The Moog synthesizer is released. 1970. ARP 2600 is manufactured. 1981. IBM introduces a 16-bit personal computer. 1983. Development of MIDI. 1984. The Apple Corporation markets the Macintosh computer. 1986. The first digital consoles appear. 1987. DigiDesign markets sound tools. 1994. Yamaha unveils the Promix 01.